So hi folks, it's really great to be here. I'm Prajakta. I'm a product manager in cloud networking in Google Cloud, and I want to invite Dee to introduce himself.
Okay, so hi folks. My name is Dee. I'm a software engineer at Tetrate. I'm a on-file maintainer.
Perfect. So a lot of things that we are going to be talking about are things that are being developed, designed, and so a lot of them are forward-looking, so just keep that in mind. But we did want to paint the whole picture, so that's why each of these products or blueprints are in here. So one of the things, especially in the service mesh space or when you look at containers, my key takeaways as I talk to different customers, each of them comes with their viewpoint. Each of them has their starting point, which could be totally different from another customer. And so what Dee and I decided to do today is just pick two customers. And what is really interesting about customer A and customer B, we shall not name them, is that customer A, they want to mesh first and then containerize, and customer B wants to containerize first and then mesh. Now, a really good question to ask is, what is driving this customer to go adopt the mesh? Like, if their life is happy and good, why do they need to bring in the mesh into their deployments? So this customer, before they even came to Google Cloud, this is a retail customer, and they used to have the entire app. It was one app, it was a monolith, and it used to take them 3 months to ship out a single change. And so actually what they really wanted was not to move to the mesh or to containerize. What they really wanted to do was to bring this time down. Like, they didn't want 3 months to ship out a change. So they took this monolith, and then they went and split it into 20 microservices. This is before they even came to the cloud. Now, once they did that, they said, it's time to go to the cloud. And so by the time they came to Google Cloud in the first few months to a year, they went from 20 microservices to 80 microservices, and the time had gone down to a day to a week. So that is the agility they were looking for, to go from 3 months to a day or to a week. And so they got that. What they also got, though, was that they went from managing one monolith to managing almost 100 plus services, and it was not easy because each of these services was a snowflake. And so that's what they said. Like, these are a lot of services to go connect, secure, manage. Can I do better? And also, I'm not going to go containerize all of them at once. Maybe I'll never containerize some of them. So can I do that at my pace? So what did they do? And this is the blueprint we built our building with them. We said, let's take your services and let's see if we can weed out the snowflakes and make them very uniform and consistent. So a very simplified version of what they have, of course. But imagine there were 4 services. Let's start weaving the mesh. Now, in each of these services, we went and injected the proxy. They used the Envoy proxy. I think that is by far the most popular proxy. We also use it big time in Google Cloud and also with a lot of our customers. So they injected that into those services. They wanted to make sure they had their DDoS defense at the entry point to their mesh. And so they deployed ingress. This was using the global load balancer and Istio ingress behind. Then they added in the service mesh control plane to manage all of those proxies. And then they containerized at their pace. They didn't containerize everything, so you notice the payment service is still in VMs. And then they lived happily ever after. You should ask me, but how? So that's what we'll get to. So here is the strategy customer A is using. And there are different strategies. There's no one size fits all. They want to use fully managed solutions wherever possible. So for their VMs, they are already using Google Compute Engine. This is in Google Cloud. For container orchestration, they're using the Google Kubernetes Engine, which is GKE. For the fully managed service mesh control plane, they experimented with Istio and GKE, but they plan to use Traffic Director. You will hear more about it next month when you come to Google Cloud Next conference, but that's essentially a fully managed traffic control plane for the service mesh. Then they said, fully managed. So who's going to go manage the envoys? And that's where Tetrate comes in. So they are providing an opinionated and certified image for the envoy. And then they're also helping with the envoy lifecycle management. And then think of your deployment. Like it's going to be a mix of VMs and it's going to be a mix of containers while you do this migration. And so you need an abstraction for those endpoints that works for both. We have something called network endpoint groups in Google, and I'll talk a little bit more about it. And then, obviously, these are table stakes, but then you also need things that make your life easy. Like, why can you not go deploy your microservice in N regions and have automatic cross-region overflow failover? Why does your mesh have to be in one cluster or one region? So there's a series of things we are building out to also solve those problems, and then we'll take a peek at that as well. So let's start with what I said, the managed. We have something called managed instance groups. This is essentially for putting in all of your instances, and it's like, think of it as a thing that holds all of your instances, and in this case, it holds VM instances. We also have an abstraction, which I just mentioned, which is NEG, the network endpoint groups. It can actually take arbitrary endpoints, but in this case, it will take containers. So that is what you have. What you notice is the unifying thing there is the backend service, and then these can be the things that actually host the backend service. Now, what this customer plans to do, and all of this is in development, but they have all of their instances for a service sitting inside the managed instance group. What you notice in the control plane is the traffic director. So that can recognize instance groups, that can recognize network endpoint groups, and it can actually have both of them for a given service. So this is the proposed model. And so what you do is now you want to take this VM service and you want to move it to containers. So you create this NEG, and that's where all of your pods are going to go in. And then if you notice, you already have the MIG. Currently, all of your traffic is going to the managed instance group. But that is where programming the mesh comes in. And that is what the traffic director will do to program the mesh. What it will do is it will start shifting your traffic to the network endpoint group. And there's, of course, we probably won't have time to go into the data model, but you're welcome to come to next and hear more. But the whole idea is that you slowly start shifting the traffic from your instance group all the way to the NEG. So now you've got traffic going to both. How much? That depends on how fast you want to migrate, what kind of gotchas you hit. Maybe there's some refactoring of your service or your app that you need to do. Once all of that is handled, then what you do is essentially you start draining the traffic. And all of this comes with the Envoy, Istio, traffic director programmability, because you can control the flow of traffic. And so you would remove this instance group eventually when you're done with migrating your app to containers. And so that's actually a very seamless way to shift your service without disruption. And the key to this is that abstraction and then traffic director as the control plane. Now, complementing this is this other thing I mentioned where people are like, we don't need to worry about, or we don't want to worry about which Envoy image to build. And so that's where I'll invite Dee to talk a little bit more.
So probably this is the third time you guys listen about Get Envoy thing. Yeah, we've been building this Get Envoy for quite some time. The background story of it is building Envoy is not an easy process, and even we have in upstream we have this issue that we kind of outbuild our Circle CI. So that's why this is an effort from Tetrate to help the Envoy community to get the build of Envoy. So we also put some effort on making it faster and efficient on building the Envoy. So basically, again, this is a certified and compliant build. So we put some effort on providing FIPS certified Envoy build with OpenSSL, and we will be patches with important CVEs if there are any CVEs, and then we also provide a clear guideline on how to upgrade it. Probably we will have another tooling on that, so you can actually upgrade Envoy, whether it's in place or you can actually integrate with your own lifecycle in your infrastructure. So we also plan to put some forward-looking. Well, we want to cover more protocols that probably won't be upstream as fast. I mean, like we will be upstreaming these things as fast as we can, but probably the customer wants to be there before we upstream that one, so we kind of want to do this. And then more private extensions. So I've been hearing in this conference, I met with some of our customer, well, potential customers. So they want like a private extension. They want to extend their own, like for example, like a Pivotal, they have like OIDC, but we have probably certain organization, they have their own like special source or something like that. So we have this plan to enable you to handpick your own extensions. So now Envoy has probably too many extensions, so we want you to be able to handpick your extension. So and also like if you have like super special or super secret extension. So what is extension in Envoy? So this is well, in Envoy, basically Envoy at its core, it is extensible. So you can extend Envoy in several points. The first point probably is the listener filters. So in that case, like if you heard AOL, it's like SNI or something like that, it's in listener filters. So after that, you go to connection, and then you can also like have these network filters. Network filters are like, well, in Envoy, currently it's only TCP, but UDP is in the process of to be there. And then after that, you have these L7 filters. Well, HTTP is the first class, HTTP and gRPC is the first class protocol that are supported by Envoy. But if you see in the Envoy repository, there are also like, for example, like TRIF. So you can also introduce like filter for TRIF. So basically, if this is L7, you can have like another filter of L7. So you can imagine that if you enabled it for example, Postgres, you can have like filter for Postgres, something like that. So we can enable that like that. So this is what we are proposing. So we take the upstream code, the good part, and then you can actually handpick your extension. You can click. Oh, I don't want gRPC web probably. I don't want to use. I want to use gRPC web. So I don't want it to be in my binary. So and then you put your own specific extension, and then we compile it for you, and we deliver the binary. So, but extension for this, extending this will be natively in C++, but currently there is an effort to put WASM runtime inside Envoy, so stay tuned. Probably interesting. So another thing that we are thinking about it is the same board for your mass. So we monitoring its version of Envoy that's deployed inside your mass. So we put a UI so you can actually see which one is not updated and which one is updated. So you can deliberately update the Envoy for a specific version or a specific deployment. So again, getting the latest and reliable Envoy build is not trivial. You can try it by yourself to setting up like Bazel and kind of stuff. And then the available packages is also limited. I mean, it's not for all operating system programming that you are interested in. And yeah, Tetrate comes to solve this problem by distributing tested and certified Envoy builds for CentOS, Ubuntu Mac, and other things. We also have like this fully static Envoy, so it's still experimental and more packaging and integration.
Thanks, Deep. Okay, so we spoke about customer A who wanted to mesh first and then containerize. I'm also working with another customer. Let's call that customer B. And actually, their main goal is to first go and containerize their services. They have multiple reasons. Some of it relate not only to agility, but also portability. So they don't want to get locked in. They are also not a US customer. They're based out of APAC. So there's certain considerations related to that also are pushing them towards containers. Now, if you look at what you see on the screen, this is where the customer started from. They essentially had one big monolith again, similar to our first customer on-prem. And they said, okay, we want to go and containerize. We also want to go move some of this to Google Cloud. So this is what it looked like at the starting point. Nothing fancy. It's your typical 3-tier architecture for an app. Now, the first thing that they did is they didn't do much. So what they did is they came to Google Cloud. They put the global load balancer, and the reason for that is our global load balancer is anycast-based. So you can put anything behind it. It can be in any region, but then you can front it with a single whip. So that is one of the big draws. The second thing is that you get built-in DDoS defense, especially against the volumetric attacks. And then there's a new feature, or there's a new product called Cloud Armor that you can layer on top of that. So that's the main reason people go. It's almost like building out your edge defense. And then what they did is they used a specific variant of an API gateway software. They were using it on-prem. There was some restriction to reuse that in the cloud, so they simply put it in containers, and then they put it behind the global load balancer. All of this now, as they came to cloud, everything that they were putting in was into containers. And then they didn't move anything to cloud, except they pointed the API gateway to the monolith on-prem. So that's how they introduced this into their setup without any disruption. Then they started carving up their monoliths. So they literally took out a service A. It was the easiest one to take out of that monolith. Also, not really critical if something happened to it. So it was non-critical and easy to extract out. And then they put it in containers in Google Cloud. And then the API gateway figured out where to send the traffic because they chunked out one part of their API space into Google Cloud. And this was containerized. Now, in addition to that, they started doing the same. So they started evaluating the monoliths, and they said, what are the services I can start pulling into Google Cloud? So they pulled out another service called Service B. Now they hit a problem where their management said, go accelerate the pace of migration to cloud, but they knew there were certain services that were not ready to move to cloud. Typically, a lot of these are payment systems or systems where the deployment is multi-cloud, and then they use that system in each of those deployments, so they just want to keep it on-prem. And so what they did is there was a new launch. I don't know how many of you are aware of something called GKE on-prem. So it essentially lets you bring in the Kubernetes management of the control plane onto your on-premises. So they are trialing that, where they essentially carved out a service C, they containerized it, but then they are managing it on-prem with this GKE on-prem. And the other thing they wanted to do is some of their services actually do support the gRPC interface. I know there was a talk prior to this, but that is, again, the high-performance interface you want to use if you can bring it in from get-go. So that is what they did for Service A. Now, at this point, they obviously went Service C, D, and all of that. But then at that point of time, they were ready to go and explore the service mesh, because it's a similar pattern. As you start seeing the number of services grow, people don't want to manage snowflakes. So they start looking for these uniform patterns. And I don't say that service mesh does everything very seamlessly, but you can see the path, like it can. It can be that substrate on which you can manage your services very consistently, very uniformly, whether you are in cloud, whether you're in a heterogeneous environment of VMs and containers, and also when you're doing things at scale. So a lot of these have to do with scale, because the number of microservices far outnumbers your one monolith that you have. So once they did that, then obviously they also went with Envoy proxy. So if Matt's here, like there's a big shout out to him that at least a lot of the customers we see are adopting Envoy. And so they put the Envoy in Service B and C. Service A, they could not inject the proxy given the way it was. So there's a different plan for it. We'll save that for another talk. But so they put it in Service B and C. Now the moment you put Envoys, just like in the service mesh, now you need the service mesh control plane. And so that's where they brought in Istio. So now you've got Istio that's managing the proxies in Google Cloud. And then they also, on Service C as well, they put the Envoy. And then you have Istio that's managing that deployment on-prem. Now, what they want to do is, like most people hate managing service control planes because that's not their core competency. They'd rather go and build their applications or their business logic. And so they are in trials with us to go move the traffic management control plane to traffic director. They will continue to use Istio till we fully integrate the two. But that's essentially the model that they will use for on-prem. And then what they have, in Google Cloud and on-prem, they continue to use Istio. And the reason for that is there are one of two things that need to happen. Either federation needs to happen, or we need to be able to manage things that are in another cloud, and I think we need both. So that is where you can see this whole thing going. And you can literally trace their steps, which is like numbered 1, 2, 3, 4, 5, 6. 6 has not happened yet, but it is, in my mind, an inevitable. Like, we have to have the consistent experiences, whether you're in Google Cloud or you're on-prem. And you'll see that trend across a lot of the launches we are doing in Google Cloud, I would say last 6 months or even before that. So this was customer B. So what did I learn from dealing with these two customers? And I think my key takeaway was this. So I think containers, people have thought a lot about hybrid and on-prem and VMs and like taking the VMs to containers. But I think service mesh, there is a huge misconception, or rather there's a perception that service mesh is for containers. And actually that's not true. Like our first customer showed. A lot of people will mesh first and then containerize. And so as somebody who's a cloud provider, which is Google, we believe that we need to be able to offer the same experience for the service mesh, whether you're using VMs or containers, and we have to let customers mesh or containerize, or even just one of those in whatever order they choose, because one size doesn't fit all, and we have to give that flexibility. And the place where we implemented this, so just so that you know it's not just talk, is when you come to next month, we are launching a product called Traffic Director, which is the traffic management control plane for the mesh. And we provide global load balancing, and it works just as well for VMs as it does for containers. So if you want to learn more, do come by, and we'd love to talk more. So with that, we come to the end of our talk. Thank you, folks.
Any questions? Yeah. Oh, already.
So is the mic on?
Yes.
That is a great question. So I think even before Istio, you have to start from service mesh, right? So if you take a look at the service mesh control plane and you just map that to Istio, you essentially have 3 things that are done in Istio. One of them is the Istio pilot, which is doing all of your traffic management and so on. Then you've got the mixer, which is your observability component, and then you've got your security bits. Think of this as being a GCP managed version of pilot. What we don't provide yet is allowing you to configure using the Istio APIs, which is what will come. But the interface between Traffic Director and the Envoy is XDS v2. So we do believe big time in open interfaces. And so like imagine you put in Istio pilot and you decided to try Traffic Director and you don't like it, you can swap it back to whatever you had with pilot. Or it could be something totally different, as long as the thing is compliant with the XDS v2 API. So if you build some proprietary interface between control plane and data plane, which is the Envoy, it's not going to work. But if you're adhering to open interfaces, then it will let you swap out. So there is no lock-in. So think of it as, once we put in the Istio APIs, think of it as being similar to a GCP managed pilot with some additional capabilities like global LB and more, for which you will have to attend our talk. Does that answer your question? Okay. Okay, yeah, you can always find me later.
I think someone there, right?
Hi. Mm-hmm. So is your question, sorry, I couldn't hear you clearly. Can you repeat it one more time? That is a great question. So, yeah, the question was, I think he had a good question, which is, as you have these Envoy proxies which can behave like your edge load balancers for north-south traffic, do things like the global load balancers lose relevance? And I think they are very complementary, and let me explain why. So, and this now I talk specifically with respect to Google Cloud, because that's where I have the most knowledge. So in Google Cloud, like maybe 2004 or thereabouts, we used to literally use vendor load balancers. And then the search traffic, this was even way before cloud, it was all search traffic and so on. And then the traffic grew so much that the load balancers couldn't handle it anymore because they used to get DDoS. The scale of search, like the search users was so much. And today they're like, we have 1 billion user plus services. So when you use global load balancer, it's not as much about load balancing. It's about getting that distributed layer in front because your egress has to be strong. It's like the edge of your fortress. You have to be able to withstand DDoS attacks. You have to be able to scale out to whatever traffic you can expect to see. And so oftentimes what we expect is eventually we will have this load balancer provide the same primitives. Like imagine if you mush together this and Envoy, like what you'd probably get that. But in the short term, what people do is they deploy the global load balancer, and if you noticed one of the slides, it actually describes that in detail. So DDoS defense, even the Anycast IPs, because if you deployed envoys, they would be single region. So imagine you put a bank of envoys behind as your gateway, and then you would put this in front. So we do expect, in fact, there are 3 ways you can deploy ingress today. One is Kubernetes ingress with the Istio ingress behind, or the envoy behind, global load balancer, which is if you're using VMs, and then there will be other third-party solutions. But nothing can beat what you can get in terms of DDoS defense and so on by putting software in VMs, right? That works great for the mesh. It doesn't scale for the edge. I don't know if I answered your question. Thanks.
Okay.
Pose a problem in Google Cloud where you have to be in a single region to achieve this? Or can you put service A, service B in 2 different regions? Service C then goes into the on-prem with the monolith, and you can still achieve all this with gRPC and API gateway.
So let's take a look at this, right? So initially, everything is... it's going to be hard, but I'll try. Correct me if I'm wrong. So, and I'm going to totally rephrase your question. So,
One second.
This one?
Yeah, this one.
You know, we should give you folks the mic.
Oh, yeah.
We are terrible at, we're just paraphrasing your questions left and right. Yeah, so in this case, I mean, everything was on-prem. So that service C that you see, it never came to Google Cloud. Like, it always sat on-prem, right? If you look at this, like first monolith, then service A chopped out of the monolith and directly put in Google Cloud. Service B chopped out of monolith, directly put in Google Cloud. Service B, imagine it's a payment system, just to simplify. It's not, but imagine it is. And it's not going to go into cloud. So you would just chop it out, put it on-prem itself. And then you need, if they want to do Kubernetes everywhere, you need something that's the Kubernetes control plane. And that was our GKE on-prem offering, which is like, imagine bringing Kubernetes control plane to your on-prem. Right, so that's what they did here. Now the gRPC bit is interesting. It has a whole backstory, which we will discuss later. But sometimes, so when you use the gRPC interface, your apps have to be ready to support that. And sometimes that's not the case. So customers cannot bring it. Having said that, there is a huge push by these customers, like while they're adopting containers and the service mesh, to go bring in gRPC. So wherever possible, like imagine I just showed 3 services, this person or this customer has hundreds. They brought in gRPC wherever possible. But in some cases, the rewrite of the app couldn't be done immediately. And so that's why they didn't bring it in. It's not that they don't want to.
Yeah, in this case, the service A and service B. Can you separate out the pods in such a way that they are in 2 different regions and the on-prem is separate? So can you still use gRPC and be able to achieve the same thing? Or does it pose a restriction where the AB has to be confined to a single region and then piggyback or hairpin into the on-prem there?
Yeah, so there are 2 parts to your question. So let's say service A and service B in GCP, and let's say they have proxies as an example, and they're in 2 different regions. With using Traffic Director, you can. So that is one of our value adds. Like you can do multi-region services, you can load balance across, you can take even one service and put, let's say, your VMs or containers, whatever you have in US Central 1, and you can put the rest of them, let's say, in US East or US West for resiliency within US itself. It doesn't have to be somewhere in the other part of the world. Or you could put it across the globe if you want, and it will send your traffic, which is what actually this last thing shows you in passing. I didn't really spend much time elaborating on that. But if you notice, the first one is US Central 1, the next one is Southeast, and it will make sure that your service, the calling service, the client side, actually goes to the closest available instance as long as it's available and not overloaded. The moment it overloads, it will fail over and overflow for you. And the reason we built it out this way is we have the global load balancer, and this is one of the big differentiators for it. And there is no reason to shortchange the microservices. Why not give them also global load balancing? So it is built from get-go to do that. Sure. I think
we have time for one more question.
Okay. Great. Thank you, everyone.
Thank you.